All right, let's go on page 98 when we're done. So we have talked about law of sines and law of cosines. Today we're going to look at solving triangles, which basically just means you got to decide which one you're going to use, and we find everything. We don't just find a side or just find an angle. So here are the law of sines and law of cosines together, all written out for you. And so the law of sines, just a little proportion thing, pretty easy to follow, right? You use this if you were getting two angles and a side because you want another side. So that means we're either using angle, angle, side, angle, which those two can both be used to actually prove triangles congruent. But then we have the ambiguous case, which is side, side, angle. And would you say law of sines is a little easier to use than law of cosines? Okay, so I had somebody in my other classes that was adamant that they liked law of cosines. They hated law of sines. Like, whatever, more power to you, but I disagree with that. Okay, and that's fine. It's a matter of opinion. But so if you start off on one of these with law of cosines, you can switch to law of sines after you get enough information to be able to do that, but you have to have found the largest angle. If you have found the largest angle, then you don't have to worry about the ambiguous case anymore, okay? And so we'll look at one of those as we go through this. So just if you have an option of which angle to find and you can find the largest one, do that, because then that helps you get the rest done, okay? All right, so then law of cosines, we would use that if we have side, angle, side, or side, side, side. Okay, so if you have two sides in the included angle, you use law of cosines. If the angle is not included, that's the law of sines. Okay? Yes, sir. Okay, if you have all three sides, how do you know which angle is the biggest? It's across from the biggest side. That's how you would know. Because, well, pictures, or if it tells me and I have to draw it. Either you already have the picture or it tells you the information and you draw it and label it. That's how you would know. Okay, so here, well, yes, and in this case, I mean, and you can't go by the way it looks, but if I add these, so what is the measure of angle B here? No, how do you find this? We add these two together, subtract from 180. What do you get? 113. So B is the biggest angle. Now that I have the biggest angle, I could use the law of sines if I have the information for that, which I could have used the law of sines before that anyway. So just saying that in that case, yes, that's how you would know, either because you have all the angles and it's obvious, or you have the sides and therefore you know. Okay, either way. Because if you're going to use side, angle, side with the law of cosines, that what you're going to find is that third side. So then at that point you have all three sides, so you would know which one the biggest angle is. Okay, we're going to start with, we'll do example 2. Okay. So I have this here, and I have to decide, well, first of all, I'm not using right triangle trig because it's not a right triangle, right? If it is a right triangle, though, let me put this out there too. If you have a right triangle, use SOHCAHTOA and do the right triangle trig you learned in geometry because it's easier. I had a lot of students on the test in pre-AP that took the right triangles and did law of sines on them, which it works, but it's way more complicated. Like, just do SOHCAHTOA like you know how to do it. Don't overthink things and make things up. So I have two sides in the included angle, right? Which means that I've got to find everything in the end, but I can find this side first. I'm going to call this side X, so I have something to call it. All right. So would I use law of sines or law of cosines here? Cosines. And you know what? If you're not sure, let's say you think, oh, I'm going to use the law of sines. Well, then you're going to find the sine of 87 over x equals the sine of p over 28. Well, you have two unknowns. That doesn't work, right? It's not going to work in the one that you can't use. When you do law of cosines, you have the angle and the side that's across from it. You know one of them, and you're looking for the other one. Okay? It's not a right triangle. Yeah. So when you are doing law of cosines, whatever this side is that's across from the angle that's being used, that's what's outside by itself. So that would be x squared equals, then what do I do with the other two sides? Square them and add them together. And then minus 2 times 28 times 17 times the cosine of 87. And you have to write that down before you type it all in. Like, that's all the work you have to show, but that has to be there. You can't just have an answer because you typed everything in on the calculator. Okay. That's part of the formula. Okay, well, it comes from the, if I showed you the proof of it, I could do that. But it comes from the Pythagorean theorem and some substitution, and it just kind of works out that way. If you watch in pre-AP, I did show them where that came from. If you watch the first 2 minutes of that video from this, it would show you that. I just didn't want to. Sometimes it just lost half of them too. But sometimes people are just turned off by that because all they're thinking is, I don't want to have to do that. I don't know that I could. But I'm not saying you have to recreate it. It just shows you why it works from the right triangle trick. So it is interesting, and I did show it. It's in there if you want to see it. All right. So when you get all that, we get x, which is actually the length of PQ. And what do we get for the number? 9, 8, 7. Yes. Yes. It doesn't state, so it's 3 decimal places. Another thing I want to make clear is the thousandths is 3 decimal places. Like, that's the go-to if it's not told otherwise. The tenth is how many decimal places? 1. And a lot of people turn in with 2. That's the hundredth. So that would make it wrong. And I didn't count them wrong on the homework because I didn't want everybody to get a 0. But those kinds of things, like on the AP exam, it's going to be counted wrong. Okay? So make sure you know that you're doing the right thing there. Okay, so now store that number. I know how to store it? Yes? Okay. Shift, recall, and I called it X so you can store it X. Do you have the biggest angle? We do, not because it looks that way, right? But because this is 31 something, right? This is the largest angle. So now, to find one of the other angles, I could use the law of cosines. There's nothing wrong with that. But I can also use the law of sines, which is going to make it a little easier. Would you agree with that? So now I can do the sine of 87 over x, and that's what's in my calculator, right? Because you stored it in x, or you can store it wherever you want. Just make sure you know where it is. That's equal to, well, p comes next, so we'll find angle p. So it would be the sine of angle p over what? 28. And so then when you cross multiply in your calculator, you literally do divided by and then recall x. You don't have to push the alpha key at all. Get my sphere up so I can. So I didn't type this in up here for you, but you got to let me know if you need to actually see it, and I will if you get confused. And it's okay. Don't feel like somebody's going to think you're stupid because you're asking. I just don't always think you need me to do every single little thing, but we'll see. So what did we get for angle? So when you do that, when you multiply 28 times the sine of 87 and you divide by x, what you have gotten is the sine of p, right? That's not your answer. So what do you have to do? Sine inverse. And once you do the sine inverse, what do you get? Good. 60.945. And that's degrees. Anybody struggling with that? Yes. 28 squared. You're in radian mode. So all you have to do is change it to degree, hit enter. Okay, and then go second mode and it quits, and then just hit enter again. There you go. Okay, you got that. But that is, so that means that this is what you typed in. Same thing with yours though, is that you typed this in, that's x squared, so you got to take the square root of it. So you hit the square root button and then answer, and you can, okay. So just hit square root and then just hit the answer button and hit equals. Okay, you good? Or you can put it all into the square root to begin with. That works too, but sometimes I forget to do that too, so you just got to go back and make sure you take the square root. That's why, in the end, when you get something, you have to ask yourself, what is this number? That's why I asked you that. It gives you the sine of p in the other case, so then that's why you have to take the sine inverse. Like, that's not the angle, okay? Are we good? Now, I have this one. Do I have to do trig to find q? No. I can just, that 60.945, if it's still looking at you in the calculator, just add 87 to it, and then subtract that from 180, and what do we get? 32.055 degrees. Yes, very good. All right, any questions about that? Are we good? Yes. What? Okay, let's look at example 4 on the back here. All right. So it says that in triangle WXY. So it gives you all this information. So we're gonna draw it. I'll draw it over here so we have plenty of room to work. So, or you can draw it over here. It doesn't matter. But WXY. WX is 9 meters. XY is 15 meters. Angle W is 31 degrees. Okay. Yeah, this is the one that doesn't work, right? It's the side-side angle, yes? So this is side-side angle. So is that law of sines or law of cosines? Sines. The side-side angle is law of sines. Side angle side is law of cosines. But again, let's say we thought it was law of cosines. So if it's law of cosines, when you have the angle and the side across from it, one of those two things you don't know. And so since I know both of them, the law of cosines doesn't work, right? So even if this isn't what's telling you what to do, if you try and put it in law of cosines, it doesn't work because you don't have the right pieces. Does that make sense to you? It's because for law of cosines, you have to have two sides in the included angle, or all three sides, not two sides in the non-included angle. So this would be law of sines, yes. So these two pieces go together. So I'm going to say I have the sine of 31 over 15. And then this side is what I have to use. And I'm going to find angle y first. So this would be the sine of y over 9. So then in my calculator, there we go. I'm going to do 9 times the sine of 31. And then I'm going to divide that by 15. Right? And that gives me this number, but that's the sine of y. So I'm going to do shift sine inverse of my answer. And I get this number right here. So I'm going to store that. We called it y. Shift, recall, y. I'm going to store it in y. And then to write down my answer, the measure of angle y is equal to 18.000. Okay. Is that my only option? No, because this was the ambiguous case, right? How do I figure out what the other possibility is? Subtract it from 180. So 180 minus that number, and that's going to give you 162.000, right? Now, are we guaranteed that they both work? No. That could they both work? Yes. Could they work? Yes. So if I take 31 and I add it to 18, that's less than 180, so I'm good, right? I take 31, I add it to 162, that's more than 180. That one does not work. Okay, that's how you decide that. I don't have any room left for my third angle. So the measure of angle y then is 18.000 degrees. So now how do I find the other angle? Good, I add that to the 31, subtract 180, and we get 131. Okay, everybody okay with that? I still have to find another side, right? So I still have angle y. Hopefully you have stored that because I told you to store it. If not, you have to go type it back in. But I can find, let's see. Oh, I don't even have to. Well, I can use angle y or x. Actually, I need x to find that side. So that 131 that you have, but not just 131. It's 131 it's whatever the calculator says, right? That answer that you got for that, you need to store that in x. Does that make sense to you? So like I'm here, I had this, I did 180 minus the answer, and I got, oops, no, I didn't want to do that. So, chutes and ladders, okay. Let's see, I stored it in y though. Recall y, I think I stored it. There you go, so there it is. But I needed to add that to 31 and then take 180 minus that number, right? Okay, so that's my x angle, yes? So I'm going to store that in x. Bam. Okay. Yes, so when you round it, like when you write it down, it's 131, but that's really what you actually have in there. So now to figure out the other part of this, I have the angle x, so I'm going to take the sine of 31 over 15, and that's equal to the sine of x, that's stored in my calculator, over the length of wy. I'll just call it length of wy, it's easier. So then in my calculator, I am doing, clear that off, I have 15 times the sine of recall x, that's literally what I'm typing in there, and then I'm going to divide that by the sine of 31. Do I have to do an inverse anything? No, because that's the length of wy, right? That's not a sine of something. That's the length of wy. So you get 21.980. And are there units here? Yes. Meters. Okay. Everybody okay with that? Any questions at all? Okay. Now, word problems. I think I want you to stop even thinking about these things like as word problems, because I think that you, just over years in school, like you have a bad taste in your mouth about word problems. You hate word problems, right? But you can't, it's how you approach them. They're not nearly as bad as you make them out to be sometimes. And I know that you've read word problems that are like a paragraph before and none of them make any sense or whatever, but you read it, right? Cincinnati, Ohio is 540 miles due east of Kansas City, Missouri. The bearing from Kansas City to Nashville, Tennessee is blah, blah, blah. Okay, so we got all that. That's a lot of information, right? So that's way too much information to comprehend all at once and work the problem. For me too, like I would never just read that and be like, oh, this is what we do. Like you have to read it, have an idea of what's happening, then you got to go back and say, okay, a piece at a time here. Cincinnati is 540 miles due east of Kansas City. So here are two cities, right? Due east means that it's along like a horizontal, right? Okay, so, because here is like, this is east, right? So if Cincinnati is due east of Kansas City, this is Cincinnati, this is Kansas City. Right? Does that make sense to you? And do you see how I did my little north, south, east, west here? I can do it. Then it says the bearing from Kansas City to Nashville, Tennessee is is from Kansas City to Nashville, so Nashville's down here somewhere, is south 64 degrees east. So here's my little compass, south, and then I swing 64 degrees east. That means this angle right here is 64 degrees. Yes, in just a second we will. And then it says the bearing from Cincinnati to Nashville. So even though I have this compass, I can redraw it right here. Redraw that an infinite amount of times. The bearing from Cincinnati to Nashville is south 29 degrees west, so this is 29 degrees right here. Did you say, wait, did I lose you somewhere? Where did I lose you? You got the bearing thing? You understand what I did with the bearing? Where are you lost? Ask me a question. Anybody else got a question? All right. Do you understand? It says, so Cincinnati is due east. This is east of Kansas City, right? And this is 540 miles. And then it says that the bearing from Kansas City to Nashville is south 64 degrees east. That's where that 64 came from. To Cincinnati, yes, because it's due east. Like there is not a bearing, like it is due east. I'm going straight east, I am horizontal. Is that? Yeah. No, okay, you good now? Everybody else okay where everything came from? Okay, so now I have that this is 540. I don't have any angles inside my triangle. However, since this is a compass, it's like a right angle right here. This is a right angle. So 90 minus 64 gives me 26 degrees right there. And 90 minus 29 gives me 61 degrees right there. So it says, find the distance from Kansas City to Nashville. So from Kansas City to Nashville, I'm going to call this X right here. Would I use the law of sines or the law of cosines? Law of sines. Now, you have to get the picture drawn to even get that far, and that's what's going to stump, that's what stumps most people are the pictures. So we're going to do law of sines. Well, I know that 61 goes with x, so the sine of 61 over x equals the sine of what? Oh, I don't have it. Can I find it, though? Like, I don't have it, but this is the angle that I need, right? So I add these two together and subtract from 180, and I get what? 93. Okay, so that means I'm going to use the sine of 93 over 540. So once I do that, don't bother me, that's not straight. Okay, let's see, I have 540 times the sine of 61, and then I divide that by the sine of 93. That gives me a side length, so there's no inverse anything, and that's what I get. Now I'm going to store that because I need, because I might need it in the second part because I'm not done with the question. So I called it x. I'm going to store it in x since that's what I called it. You can call it whatever you want. Just make sure you know where to find it. Okay, so then I have to say that, I can say that Kansas City is 472 point what? 943 miles from Nashville. Well, yeah. Otherwise, what's it that far from? Got to answer the question. All right, so then it asks me for the distance from Cincinnati to Nashville. So I'm looking for this right here. I'm going to call this y. So I didn't actually need to store x, but I didn't necessarily know that at that point, so it's better just to store it so you don't have to go back and recalculate it. Because I could use it, like I could use 61 over x and use what I found, but if I messed it up, then I'm just out of luck. Or I can use the 93 and 540 and the 26 and y. That makes more sense to use what they gave you. So we'll do the sine of 26 over y is equal to the sine of 93 over 540. And I would say after we find this, there's really no need to store it because we're done with the question. Right? And so I will get that distance from C to N is what? 0.45 miles. And you can like state the answers either way. I mean, you're answering the question no matter how you word it. You just gotta make sure you actually answer it. Questions? Okay. So I want you to read number 6, and I want you to just kind of think about how you would draw it. And then I'm going to help you draw it, but just kind of think through it. You can sketch something out if you want, and then I can, I just don't want to just do them all for you. Give me a second just to think. And don't be afraid to write something down and draw it. Like once you draw it, it's in front of you. If you see that it's wrong, then you change it. It's fine. I mean, you don't have to be perfect on it every single time. Which one am I on? So you go north 45 degrees. So you're at north, and you go 45 degrees to the west, like that way. So your angle is right there. You're good. So once everybody has a picture, I know some of y'all are calculating, and that's fine, but once you have a picture, kind of put your pencil down, because then I'm going to draw it and walk you through it, and you can either just follow along, or if you want to like redraw it underneath, if you feel like it's not right, just don't erase yours. Okay. Yeah, it's just the point where they started. All right, so can I draw it now? You can follow along. If you want to redraw it with me, you can, but maybe yours is perfect and everything is great. So let's just look up here. So leaving from the same port. So here's where we're going to leave from. And so I'm going to have a bearing. So I'm going to put my little north, south, east, west here. It says ship A sails 8 miles on a bearing of north 45 degrees west. So I'm going to go north, but then swing 45 degrees west. This is ship A, and he went 8 miles, right? And this is 45 degrees right there. Okay, does that make sense? So then, still starting from this same point, because this is the port, right? Then the ship B is going to go 14 miles at a bearing of south 70 degrees west, and 14 is going to be longer than the 8. So this is going to be 14 miles, and this is 70 degrees. Does that make sense? And then I'm going to connect these two. Whoops, there you go, just make my point bigger. And so the A part says, so anybody have any questions at this point? We get this? It's good if you can get that drawn. Okay, so the nearest tenth of a mile, how far is ship A from ship B? Okay, so we're looking for this. I'm going to call it X. So I need an angle inside my triangle, right? So I am going to use cosine, but I have to have this angle first, which I'm capable of finding. I just don't have it. But the reason that it's good to draw the north, south, east, west, which are little dotted lines, is because you have this right angle right here, right? If this is 70, then this piece right here is 20. If this is 45, then this piece right here is 45. So altogether, this angle is 65 degrees. Does that make sense? And if your picture is teeny tiny and you can't even see what's in it, then you're not going to be able to label your stuff. Like, you got to draw not super teeny tiny pictures anymore. Some of y'all are crazy about that. Like, you have to be able to label stuff in there. Because this part's 45 and this part's 20. Does that make sense? Okay. Everybody good so far? So is this law of sines or law of cosines? Cosines. Good. So on the outside we go x. X squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 65. So in my calculator, I'm at my square root, do 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 65. And if you're going to put it all under the square root, you have to close those parentheses or it's not going to take it. Equals, and that's what I get. Yeah, because you can kind of do it all in one thing. And yeah, that's, you know. Well, but depending on, if you're looking for the angle, it's not quite as simple, though, too. You know, it just kind of depends. And it's fine either way. All right, so then I'm going to say ship A is blank miles from ship B. How many miles? 12.9, because it says to the nearest tenth. You've got to read that, guys. Reading those instructions are so important. Okay. Everybody good so far? Any questions at this point? Now, I may or may not need that for the next part. So since I already have it looking at me, I'm going to store it in X because I called it X. So shift, recall X just in case. Okay. Yeah, store everything. I mean, it's not that big of a deal. Once you get used to it, it's real quick, so it's there just in case you need it. All right, so now it says, if ship A sails to ship B, oh, I didn't label my B. This is ship B. If ship A sails to ship B, what bearing should it take? All right, so we got to figure out, first of all, what we're looking for. So ship A is going to sail to ship B. So the bearing is going to come off of this right here, right? So my bearing to get from A to B, it's going to be south something west. Do you agree with that? So it's going to be south something west. I at least know that, and I'm looking for this angle right here. You with me? In my triangle, I'm not capable of finding that angle by itself first, right? But what I can find is I can find this angle. You agree with that? Like I can find angle A. So if I find angle A, then I have to decide how in the world I figure out what that is to subtract from it, right? So any idea what this angle measure right here is? 45. Not that you can tell from my bad picture, but the east-west lines are parallel. Like they don't look like it because it's bad, but these are parallel lines, right? And then this right here, these are alternate interior angles, and so are these. Because you got parallel lines cut by that transversal. Does that make sense to you? That geometry there is important, guys. And I know my picture is not the best, but some of yours, I promise you, are like tiny and you can't even read what you wrote in there. But this angle is the same as this angle. And this angle is 45, so that's 45, so that has to be. Does that make sense to you? So what I want that's going to go here, it's the measure of angle A minus 45. That's the angle that I want. And so I'm not saying you always have to write this stuff down, but again, it's not a bad idea, so when you get done, you don't forget to do that last step that you need. Ask me a question if you've got one, because I heard a lot of ohs, but not everybody might have clicked yet. Do we all understand why that's 45? Yes, that alternate interior angles? Okay. So we're capable of finding A. So have I found the largest angle already? No, because angle A is the largest angle, right? So since angle A is the largest angle, law of sines is not really that safe right here. If it is, then I have to test my others and do all that stuff. So you can do that, just know that you're going to have to test the angles. Or we could do law of cosines. Which one would you rather do? Cosines? Okay, well that's probably good because we can do another one. So I'm looking for angle A, and I know 14, because remember these that are across from each other are related. So the side goes outside by itself. That's equal to the other two sides squared and added together, so 8 squared plus x squared, glad that I stored it, right? Minus 2 times 8 times x times the cosine of A. Now I'm going to write the step that you may or may not want to write when you put it in your calculator. It's up to you, but just so that we're all on the same page here. I would do in my calculator, because I'm not going to, actually calculate this stuff by hand. Oh, my stupid thing here. I'm going to get 14 squared minus 8 squared minus x squared, right? Because I'm going to subtract these two away. This stuff here is all being multiplied by the cosine of A. So I'm going to divide by negative 2 times 8 times x. That's going to leave me with the cosine of A. So you can do cosine inverse and type all that in, and you can type it in a fraction if that's how you want to do it. So I can do cosine inverse of my fraction, and that's going to be, oh, I don't have this one written down this way, 14 squared minus 8 squared minus x squared. And then in the denominator, I'm going to have negative 2 times 8 times x, sorry. A little brain fart there. Times x. I had a bad feeling I had something wrong there. It does look weird, because when you do times x, and you don't even actually have to put the times, like you can just stick it on there, but you got that angle, right? So what we have is we have the measure of angle A is equal to 80.676. Now on this one, does it say to the nearest 10? It doesn't, I know, it's tricky, but okay, is that my answer? No, because I've got to subtract, right? So your answer to answer the question, right? And we can just say that the bearing is south, how many degrees? Good, 35.676 degrees west. And because we figured out this whole southwest thing before I ever started, it's good to think through these things before you get lost in the math and then don't end up answering the question right, okay? So those extra few seconds you take to think through the problems can be really, really helpful. Yes, sir. Mm-hmm. Oh, that's fine. If you put it in minutes and seconds, like if it doesn't distinguish which way and you want to do it that way, that's absolutely fine. Yeah. I mean, if it says you have to do it one way, that's a different story. But yeah, that'd be fine. Okay. And so you want to think about that's fine. That's absolutely fine. That's good. All right. Any other questions? All right. Do you want some help drawing those pictures on that homework that was really supposed to be due today? Yes. If you don't need it, that's fine. That's good too. Let me hand this out, and then if you will get the other out, I will help you with those pictures. I said I would give you another day if you needed it, so if you don't want to turn it into, that's fine. If you feel like you're fine. Who had asked me first? Somebody asked me before. It actually was him that asked me first. You were like third in line. Yes, you can go. Because it was him, and then it was somebody else. I think it might have been Tony. And then, I don't know, somebody else asked me. Okay. So